All right, the big dog here, Khan Academy Algebra, Systems of Equations Elimination Challenge. So that means these are going to be harder. So like right away when I look at this first problem, I notice that I have a 3 and I have an 18. So there's no way to add or subtract. I have a -4, a -5. No way to add or subtract. No variable will get eliminated. So I need to multiply either one or both rows by a number. So this is my strategy. A couple sections ago we did elimination strategies that kind of got us up to this point. So now we can actually put them into play. So let me go where I have a little bit more room. So I like to always add the equations. Kids make a lot less mistakes when they add than when they subtract, especially when you start dealing with negatives. So addition is much easier. So I am always going to try to get opposite coefficients. Okay, that's going to be huge. If I can get opposite coefficients, then my chance of success is going to go way up. So looking here, I noticed that I could multiply the top row by 6, and I would get both 18s, but they wouldn't be opposite. So I'm going to multiply this top row by a -6. So when I multiply that whole row, I get -18x, +24y, and then -48. Be very careful that you are doing it towards all three people. You're distributing it all the way through. The bottom I can just kind of copy. 18x minus 5y equals 10. And now, when I add these two up, I'm going to have some opposites. -18 and +18 are going to cancel out. And I'm going to be left with 19y equals, well, a -48 added to 10 is going to give me -38. And these numbers look kind of nasty, but they actually work out really nice. When you divide by 19, you get y equals -2. So my first variable is done. Now, just like we've done on all the other ones, I need to take that -2 and I need to substitute it in. I'm going to use this top equation. The numbers are a little smaller. So I'm going to go 3x minus 4. And instead of y, I'm going to plug in -2 equals 8. And I have 3x, -4 times a -2 is a +8. And subtract the 8 from both sides. Gives me 3x equals 0. And divide both sides by 3. So I get an answer of 0, and I get an answer of -2. Let's just kind of go back and let's put that in the problem and see what we get. 0, -2. Hopefully I get my little bell. Awesome. All right, next problem you notice is set up a little bit different. It's kind of funky. Couple things going on. Number one, the y's are in the first column. The x's are in the second column. My constants, or my numbers by themselves, are in the third column. And then I got zeros over here. So the first thing I'm going to do is I'm going to kind of move these constants over to the other side by doing the opposite. So if I add 11 to both sides, I'm going to end up with -9y plus 4x equals a +11. You know, really I just put plus 11 on both sides. And I'm going to minus this 31 from both sides so that I have -3y plus 10x equals a -31. So now at least it looks a little bit more normal. It's in standard form. Well, now when I'm kind of looking at this and I'm trying to develop a strategy, you know, the x's, I can't really multiply 4 by anything to get 10, you know, without using decimals, and I don't want to do that. It looks like on the y's, if I multiplied the bottom row by 3, I would have a -9 and a -9, but I want opposites because my ultimate goal is to add them together. So since I want opposites, I'm going to multiply this whole row by -3. And so here's what we're going to kind of end up with. I'm going to have -9y plus 4x equals 11. I'm not messing with the top row. The bottom row, I'm going to have +9y minus 30x equals, that's going to be a +93. So now my constants are my coefficients are opposites. I can add them together. The y's are going to eliminate. I'm going to have negative 26x's equal, it's at 104. And luckily for me, that goes in there exactly negative 4 times. So my x is negative 4. Now I can go in any equation, and I have 1, 2, 3, 4 equations I could choose from. I don't know, I'm going to choose this equation right here to substitute it in. So I have a negative 9y plus 4 times x, which we now know is negative 4, equals 11. That's kind of a crappy negative 4 there. Let me just fix that. And then we got negative 9y minus 16 equals 11. Add the 16 to both sides, and I get negative 9y is 27. Divide by negative 9, divide by negative 9, and y equals negative 3. So let's come over here and let's check that out. Negative 4 and negative 3. So negative 4, negative 3. There we go. Now, the hardest one of all is when you can't just multiply one row by a number to make them match up. So for instance, I'm looking at this problem here, and I can't multiply 4 by something to get 7. Unless I use fractions, I don't want to do that. I can't really multiply x by anything to get 10 without using fractions. I don't want to do that. So what I'd like to do is I'd like to find a common denominator that those numbers could go into. And, you know, it doesn't really look like there's anything jumping out at me. I think the LCD for 7 and 4 would be, I think 28 is the first number they both go into. And the LCD for 3 and 10, the first number they both go into is 30. Sometimes you get lucky and it's a smaller number. So in this situation, it looks like if I just multiply each row by the other coefficient, we should be in business. So, I don't know, let's try to eliminate, let's go ahead and eliminate x's. So, I'm going to multiply this top row by 3. Because what that's going to do, it's going to give me a 30x on the top. But then on the bottom, I want a negative 30x. I want that to be the opposite. So it looks like if I just multiply by 10, that'll achieve my goal. And 10, I picked 10 because it was a nice number that it's easy to multiply in your head instead of the 7s and the 4s from up above. So let's do this. We got 21y plus 30x equals negative 33. The bottom row, we're going to have 40y's minus 30x. I get my opposites I want. Equals negative 150. And I can now combine them by addition. I'm going to get 61y. X's eliminate. Then over here I get, what's that, a negative 183, which these numbers look pretty nasty. But once you kind of bust it out and you divide by 61, it's looking like it goes in there 3 times. I was a little bit nervous. Negative 3. So now I'm going to go back and I'm going to substitute negative 3 into whatever equation looks the nicest. Maybe I'll do this one. So instead of 4y, I'm going to do 4 times a negative 3. Subtract 3x, negative 15. That's negative 12 minus 3x equals negative 15. And I want to get the variable by itself, so let's leave the negative 3x alone and let's add 12 to both sides. And I'll get negative 3x equals negative 3. Divide, divide, and I get x equals 1. So I'm getting 1 and negative 3. Let's hope that this checks out for us. So 1, negative 3. Just like downtown, we're all set.